All right, so our physical properties of alkenes and alkynes. They're very similar to the properties of alkanes and alkenes, and alkynes are all non-polar. So they don't dissolve in water, not water soluble. Similar to alkanes, the longer carbon chain in an alkene or an alkyne, the higher the boiling point. Due to a larger sum of London dispersion forces. Now, the boiling point of alkenes, so like if I looked at a butene compared to butane, the boiling point, say, of the butene is slightly lower than those of alkanes that have the same number of carbon atoms. Alkynes, however, have a higher boiling point than alkenes and alkanes. So if you looked at this chart, let's just look at, okay, what is our highest boiling point here? Out of the whole chart, which one is the highest boiling point? Our hexyne, right? This is the highest boiling point because it has the most carbons, and it's the yne of the one that has the most carbons. Which one is our very lowest boiling point? Ethene. So because the ethene compared to ethane is a little bit lower, and this is the one with the lowest amount of carbons. Okay? Okie doke. Rock on. Now, you have, for your first question in your assignment, I'm going to actually do it with you. Because I haven't given you this information yet before for question 1, so I'll just give it to you. Okay, so question 1 reads, 1A, I'll do 1A. What is the general molecule formula for each family, talking about alkanes, alkenes, and alkynes? So this is the formulas. So here, alkanes. So it would be, if we were to represent the general overall formula, it's Cn with H of 2n plus 2. So say we looked at butene, so an example is like C4H10. That's butene. So it was 4, and then you go 2 times 4 plus 2. Okay? Okay. So then alkenes, I'll do it in a different color. And we'll say this is butane. Okay? So now alkenes, theirs is CnH of 2 times n. So an example, let's continue with our buttes here. Let's have, if we had C4, so if I have C4 and it's butene, so there would be 8 in butene, okay? So H8, which makes sense with our formula, right? We take, if we have 4 there, then we times that by 2 to figure out how many H's there are. Okay? So this is called butene. So the last one is our alkynes, is Cn of H of 2n minus 2. So we take away 2 more hydrogens. Remember how you guys noticed that whenever you went from a single bond to a double bond, you took away 2 hydrogens, right? So look at this. You start with 2n plus 2, then you take away 2 hydrogens. Then you take away 2 more, right? Every time you add another bond to the carbon, you have to take a hydrogen off of each carbon. So that's why it decreases by 2 each time. See? Okay. So say, for example, we have butene, yeah, 1, 2, 3. So like that. So we have 1, 2, 3, 4, 5, 6 hydrogens. So we'd be left with C4H6. Okay? That makes sense because it goes with our formula. We have a 4 there, we times 2 by 4, and then we minus 2. Okay? So that's the overall formula. So now you should be able to answer B and C for those questions. And then the rest, you can do some practicing. It's not a very long assignment. So yeah, you should be comfortable to finish it